Okay, good morning class and welcome back to Math 11, Finance and Workplace. The last couple of lessons we've been looking at applying our trig ratios to problems. The last lesson we worked just with the triangle figures, but today we're going to progress from that and work it into word problems. Just as I specified the other day, whenever you have a problem, you have to decide which trig ratio you need. And the best way to do that is to make a drawing first. You read the problem. It all has to do with right angle triangles. So make your right angle triangle. You know one of them is going to be 90 degrees. And then depending on how the problem is worded, you decide which value goes where on the triangle, what they tell you, what you know, and then you decide what you need to know. Once you have that, then you have to label your triangle. If they give you an angle here, then you have to label it to what side you have. This is always going to be the hypotenuse because it's opposite the 90-degree angle. Opposite is always opposite the reference angle. And the last side, of course, is your adjacent side. Now, depending on which pieces of information they give you, that will determine which trig ratio. I always put this down on my paper so I can refer to it. If they give me the opposite and the hypotenuse side, then I know I'm working with sine. If it's adjacent and hypotenuse, I know I'm working with cosine. If it's opposite and adjacent, then I'm working with tangent. Sometimes they're looking for a side, sometimes they're looking for an angle. So we have to determine that as well. So I've listed this, I put this on your lesson sheets. Sketch the diagram when it's not provided. Identify the known and unknown values. Select the right trig ratio. Put the values into the ratio. Isolate your unknown value. Usually you're putting an X to determine an X if it's a side, or you're using probably theta symbol for an angle if you need to find the angle. And then check the answer if it makes sense. What I mean is that if you're looking for, say, a side, say you're looking for this side, and this side is 2, and this side is 4, and you get an answer here of 3, well, you know it's not reasonable because this has to be the longest side. The hypotenuse has to be bigger than the other two. So if you get an answer different from, say, 5 or 6, those are reasonable. This is not, because it's too small. It's too short. It has to be bigger than 2 and 4. So we'll go for an example first before I give you the assignment. It's going to be a very short lesson today. Shelby's part of a group of volunteers who are helping with a forest inventory. She uses trigonometry to determine the height of trees. Too small to measure. Plus the fact she probably doesn't want to climb the tree to figure with a measuring tape to figure out how high it is. Use trig. What if it was a flagpole? What if someone asked you how tall is that flagpole? Well, you can't climb up a flagpole because there's no branches on it, right? But you can use trig to figure it out. Good example is, hey, this is my flagpole. Okay. And I want to know how high that is. Well, one easy way is you just measure the distance from the bottom of the pole out to here. Say you measure 10 feet. And then you stand there and you take an angle measure with a clinometer to the top of the pole. You find out what that angle is. There's instruments that we use to measure the angle. Once you know this angle and you know this side, you can figure out this because you have this side, which is the adjacent. You have this angle and you're looking for here the opposite, then you're going to be using tan. Tan of this angle will tell you, without climbing that pole, how high it is. So trig helps, and it works in this case because she needs to find the height of trees. Now the top of a balsam tree, balsam are those Christmas trees that have needles all the way around them. Okay? No. I'll trick you, right? Balsam firs, they're flat. They have the needles just on one side. So we look at it sideways, the flat. A spruce one would have needles all the way around it. Okay, while a fir tree would be just flat. Okay, that's how you can tell the difference. Most people like balsam fir best because they're not as sticky as spruce trees. Anyway, getting back to our question, the top of the balsam tree makes an angle of 65 degrees. That's not, should be 650. It should be 65. That's a typo area. That should have been a superscript to make it a degree sign, 65 degrees. With the ground at Shelby's feet, Shelby stands 25 meters from the base of the tree. Base is the bottom. Base is the bottom. How tall is the tree to the nearest meter? So that tells us our answer is not going to have any decimals. We have to round off to a whole number. So the first thing we do is to draw the pitch. Oh, won't let me do it. I'll do it myself. Okay, there's my tree. I'm not a very good artist, but let's pretend that that's the tree. It tells me that the top of the tree makes an angle of 65 degrees with the ground. So here's the top of the tree, makes an angle with the ground. There's an angle here. That's going to be the 90-degree angle. So if it makes an angle with the ground, is it going to be this angle or this angle? The top of the tree. Where should I put it? The top makes an angle with the ground. If we're standing there, we're looking at the top. The angle of the top of the tree with the ground is going to be 65 degrees. She stands 25 meters away from the base. There's the base. That's where she's standing. So this is 25 meters. This distance here to here. How tall is the tree? How tall is the tree? This is what we're looking for. So we create the diagram, put down the information. Now we have to determine which trig ratio to use. Well, our reference angle is here. That means this side is the opposite. This is our right angle. That's a hypotenuse. That's opposite that. The side opposite the hypotenuse, opposite the right angle, is the hypotenuse. And we're given the side which is adjacent. So I look at it. What am I given? A. What am I looking for? O. Well, the only trig ratio that has O and A in it is TOA, tangent. It's not SO, it's not Ka, it's TOA. So I know I have to use tan. So then I write tan of 65 degrees equals opposite over adjacent. Tan 65. My opposite side is the one I don't know, so I can use the x over the adjacent side is 25 meters. Remember, any whole number can be put over 1. Doesn't change it. So now I have a proportional statement, and I can solve it by cross multiplying it. 1 times x, 1x, right? Equals tan 65 times 25. Now I go to my calculator. So depending on the type of calculator, sometimes you can put 10 in first, sometimes you have to put the degree in first. In this one here, I have to put the degree in first, so I put 65, and I go to tan, and it gives me a decimal fraction right away, 2.144, and then I multiply that by 25. And it has 53.61 and a whole bunch of numbers. I don't have to write them all down. I just have to put at least 2 of them, because I have to go to the here number. It wants to the whole meter, nearest meter. So that means I have to decide whether I leave this as a 3 or go to 4. Well, this is 6, so that means it is 54 meters. Now, because it's a word problem, I'm going to answer in a sentence. How tall is the tree? The tree is 54 meters tall. Don't forget the units. That's also important. 54 feet, 54 meters, 54 inches, big difference. Okay? Any questions on the process? Make a diagram, label it, decide what's given, what's not, what's your trig ratio you need, find the unknown value, check to see if it's reasonable, answer in a sentence. So, these are the questions on 320 and 321. I'm going to hand them out to the class in the TC, and they'll be attached to the lesson for the people at home. There's 1, 2, 3 questions on the first page. Sorry, yeah, 3 questions, 3A, B. And I think there's 2 on the second page. 4 and 5. Just on reference to number 4, this person, Oliver, was solving this problem and it shows their calculations. What you need to do there is to see whether they did it the right way. Did they choose the right ratio? There's an error there. Where did they go wrong? Did they use the wrong ratio? Did they multiply it the wrong way? So this is how a teacher can look at someone's work and say, oh, this is where the mistake is. Okay? So you're going to be pretend you're the teacher today. You're looking at this solution and this problem and identifying where's the mistake and then put down the right one. Okay? All right, so that's it. I'll hand out the assignments to you guys.